Well, thank you very much, Charlie and James and the Tech 2025 attendees. I very much appreciate the opportunity to talk to you. I'm going to do a little bit of a different presentation today. I'm not talking technically. I'm talking about how to be a smart AI user. There's an awful lot of noise out there, and it's pretty important that we know how to cut through the noise and get to a place where we can use AI in an effective way without being fooled by bias or other kinds of problems of inaccuracy within our AI systems. Another way we might think about this is how to avoid the epic fails, because I've seen a lot of epic AI fails over the years. A little bit about me. I'm a former college professor. I have 3 computer science degrees, but Windows still crashes on me, you should know. And lots of publications and grants and 3 books. My latest one is Link, which is currently on the market. I had a great opportunity to move from being a technical geek to being an industry analyst, which meant that every year I would interview hundreds of vendors and hundreds of people that wanted to use technology. So both the buy side as well as the sell side. And that's pretty cool, right? Because you start to identify where are those gaps, where are people selling things that people don't actually want, and where are things that people want that aren't being sold. And that was kind of the value that I brought to my market, was to help people understand those gaps. Today, I run a machine learning and decision intelligence company called Quantellia, and we do software and services. So like James, I think it's important because I'm going to say some fairly radical things. I want to ground some of that radicalism in lots and lots of experience. I've been delivering applied AI solutions for over 30 years after having played the academic game and invented something new, which is actually taking off here 30 years later, called transfer learning. I'm now happy to say I've had the awesome opportunity to work in hazardous waste detection, forensic hair comparison during the OJ trials, machine vision systems for counterfeit circuits, some health stuff, stock price prediction, a big budget for the US courts and the government of the United States, and a bunch of other stuff. This is just a selected list. And after having done all of these AI projects, there are A, some systematic patterns where people make mistakes, and B, some systematic messages that we get from the AI community that turn out to be wrong. So just to give a little bit of a background, I'm not going to spend much time on this slide, but this is how I see AI. Back in the last AI summer, which was in the 80s, AI goes through these cycles. It was named in 1956, and then they ran into some technical problems, and so it sort of died out in the 60s and 70s, took off hugely in the 80s with giant investments by Japan, the United States, the UK, and then it had another winter. AI woke up again maybe 10 years ago. And this particular summer, we're all excited about something called supervised deep learning. And that is a subset of machine learning as a whole. But there's a lot of AI that doesn't learn. That includes expert systems and a bit of decision intelligence. From where we sit, I think there's a massive number of unsolved problems within AI. We are just in the infancy of this discipline. It is not yet mature. And definitely, you don't have to worry about the robot apocalypse, unless we have self-driving cars that can be hacked, and that is scary. So, but that's not AI being a problem. So machine learning, as you saw on that last slide, is kind of synonymous with AI because it's what's really big, the supervised deep learning. And so when everybody talks about machine learning or AI these days, they call it the same as machine learning. That's not strictly true. There's a lot of things that don't learn that are AI. And here's where we are on Gartner's cycle. They say, you know, machine learning's been hyped. It's about to hit another winter, and a little bit, it's going to have a correction. There is some hype, but it's much more substantive than it ever was. And then this is this new field that I invented a little while back called decision intelligence, which is very, very new. You see, it hasn't even been hyped yet. So not too many people have heard about it. Okay, so I heard in the introduction some of you talking about how you were trying to learn about AI, you were Googling things and trying to get on top of this. This is hugely hard, and the reason is that AI was invented in 1956, And it has been the domain of academics and PhDs pretty much the entire time. So I like to say this is analogous to like if the automobile industry was rewarding people for developing new kinds of engines. So we have thousands of Wankel engine and 4-cylinder and 5-cylinder, but we haven't invented a standard steering wheel and brake pedals, right? And every single engine, you have to have a different kind of steering wheel. And so if you Google AI, you'll find all the stuff about these algorithms, these engines, but it's not easy to figure out which of those are mature. Are they ready to build into a car? And which ones, you know, are just really fast things where the fuel efficiency is, you know, really bad. So we never want to actually use them. So there's just this big, giant pile of AI, and 1% has about 99% of the value. And so the pattern here is that we need to wave through this and to find that 1%. And I'd like to think, I could be wrong, that after having done this for way more years than I like to admit, I know where the 1% is. And so let me warn you, if you start Googling or going to conferences about AI, a lot of the conferences are still academic. And so everybody's incented to create new AI algorithms, new engines, great. But let's get them into practice. Let's get somebody to use them. And this is the other problem. We like to think that when we're trying to choose, you know, whether we're going to do AI or not, we're using a rational process. We're kind of thinking it through. If I have an AI system or I buy an HR, you know, recruiting algorithm from a vendor, you know, how is that going to benefit me? What are the downsides? What are the upsides? How can I maximize the value while minimizing the negatives? It turns out, and I hate to say this, that really what happens is it's so complicated that people tend to buy AI systems, but because it's so hard to understand, they buy it through social signaling. They buy AI because other people bought AI, and they say other people are doing this, so it must be good. And that's functional sometimes, but when you have a domain that's been so hyped by Hollywood, the social signaling channel is actually a little bit corrupted, right? And so it's really important to sort through the people that you are listening to if you want to do good AI and use it for something and not have negative consequences. Make sure they've implemented it in big systems and it's been used and measured, because lots and lots of researchers are just developing new algorithms, as I said earlier. So again, the good news is there's just a few key ideas that will make a big difference, and this is the 1%, and I'd like to share a few of those key ideas with you. So I want to teach you to be a really smart AI user in the next 6 minutes. How am I doing on my time, Charlie and James? I didn't set my watch, so I don't want to go over. Sorry?
No, you're good. You're good.
Okay, warn me when you'd like me to stop in 2 minutes, and then I'll just flip through these and they'll be intriguing. So key number 1, don't allow people to, you know, baffle you with techno gobbledygook, okay? Ask a very simple question. What goes into this AI system? What comes out of it? How does that achieve my goals? And why should I trust it? And 9 times out of 10, you'll ask a PhD and they'll say, well, the reinforcement conjugate gradient optimization of the minimal decision surface is working in a multi-layer perceptron, blah, 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 and every other word will be jargon, right? Don't let them do that. Say, I just want to know about the outside of the box. I believe you that this works. Please don't open the hood of that engine. Show me the steering wheel. Is this car going to get me to the grocery store, right? So focus on what this does for you. It's what it accomplishes as opposed to the inside. Key number 2, don't let the shiny objects distract you from what's useful. So you go to conferences or you Google AI and it'll say, and I was on NPR's Marketplace like a month ago and they said, oh, Google's got this article about real-time translation. They're going to put this thing in your ear and it's going to simultaneously translate. And I looked up the article. It was a brand new article. It had only been tested on a toy problem. And that's great. It's wonderful to have new research. But the thing I invented called transfer took 30 years to mature. And so we really need to be savvy about what's new and what's mature. And sometimes we call this the technical readiness level, the TRL. So ask people, don't be distracted by robot apocalypse and breakthrough results. Ask, what's the benefit? As James correctly said, is this going to get me something faster? Is it going to be the same thing but cheaper? Is it going to be a better thing, but not faster or cheaper? Or is it something brand new and original that other people don't have? Because sometimes that can be a differentiator. And then really ask, how well proven is this? How did you measure that this was a good AI system? And they'll start down the road of, well, we did the conjugate gradient ROC of the AUC and the false positive and the false negative ratio. Don't let them go there. Say, you must explain this in terms that I can understand. Insist on that, okay? Because you need to be thinking clearly about AI systems. And the culture here is so technical that it's really inhibited our ability to implement them. So this is AI in a single slide. And James talked about training data. This kind of clicks into that a little bit more. So we have these giant, massive databases all lying around. I think a 747 puts out a terabyte of data every minute or something. That's like a 1 with, I don't know how many zeros after it. I think it's 12 zeros. It's a huge amount of data. And so everybody's saying, well, you know, we've got this billing data from this telecom company and this banking data and this customer data. You know, how can we use that? So that data was not created for your hiring purpose. It was created for some other purpose. It was kind of left behind from something else somebody did. Maybe they had a database of all the people they paid, and it was a payroll system, and so it had everybody's name and how long they'd been there, right? So we're taking these existing data sets, and my example here, this is a really simple one. Say you've got all this historical data about cars, and it says like, how heavy is the car? What color is the car? How fast does it get from 0 to 60? And then you know the miles per gallon of each car. And so you have like each car is a row. I mean, the training data is really simple. It's just a big table of data. It's got rows and columns. Each column is like color or weight or something. And then the last column is the thing that you want to calculate, that you want to tell the computer to do. And so James is right. Instead of writing a computer program, you just say, for this input, give me this output. For this input, give me this output. And it's really simple. It's just a big table. It's not too hard. Feed that to the machine learning box. Don't worry about how it works. It produces something called a model. And I just always draw models as triangles. I don't know why. And a model's just a program that the computer has written automatically. And what it can do is it can take all of those features of a car it's never seen before, like it's blue, it weighs 2,000 pounds, it goes 0 to 60 in 5 seconds. And based on having analyzed all that historical data, it'll say what the miles per gallon is. That's it, guys. That's 90% of AI today is this, what we call, here's jargon for you, but it's good to know a little to get some cred. This is called supervised learning. And it's just taking this big table of data and showing the inputs and the outputs, and then the machine turns away, and then it creates this computer program automatically, which is pretty cool, because these sometimes perform better than any humans can perform, and certainly in many cases they're faster and cheaper if you can get good performance. So key number 3, that's it, okay? Don't be bedazzled by, I mean, there's certainly natural language programming, and if I had more time, I would go into that. And that's probably 20 to 30% of AI right now, hugely taking off. It doesn't fit this paradigm I'm showing you here. So I'm a little oversimplifying. Key number 4, I just read yesterday, the Denver Pitbull ban was ended. So there used to be this law, like last week in Denver, where I am right now, where you weren't allowed to have a pit bull because they were considered dangerous. And the reason for this is there was all this data that said, you know, here's some training data, seriously. It's a pit bull, yes, it's not a chihuahua, and it's aggressive. It's not a pit bull, it is a chihuahua, it's not aggressive, right? So we have these 3 rows of data. I don't know if you, 4 rows of data. I don't know if you can see my mouse. So let me go back a little bit because I hit the button wrong. So that's training data. And you know, you could feed that to a machine learning algorithm, right? And that machine learning algorithm would say, you know, you feed it like something that looks like one of these rows. It's a pit bull, it's not a chihuahua. It's going to say 1, right? Because everything that's a pit bull and not a chihuahua has always been aggressive, all right? And this is like the example you were saying about, you know, does buying a new car make you rich, right? It turns out that it's not the fact that they're pit bulls or chihuahuas, it's whether they've been well trained. But that's not enough, because guess what? People buy pit bulls and train them to be aggressive. They don't train them to be gentle. And so we don't have any data for something that's a pit bull, not a Chihuahua, and is well trained so that we can realize that it's not aggressive, right? And the reason for this is this feedback loop. So there's lots of aggressive pit bulls out there. People who want an aggressive dog get a pit bull and train it to be aggressive. People who don't want an aggressive dog, who want a sweetheart dog, don't get pit bulls. So we have more pit bulls that are aggressive than other breeds, and we have more lots of aggressive pit bulls, okay? This pattern where we have this feedback loop around something that is only the superficial thing, but isn't really the causative reason, as I understand from my dog trainer friends, having a well-trained pit bull, they're like total sweethearts and you don't have to worry about them, right? But because nobody was doing this because of this fiction, we got this feedback loop. And you guys, I'm sure, can imagine how this might map across to race or gender or other minority populations where we just don't have any data that shows that under certain circumstances, these populations do really well. And this book, this DI book is really about that kind of thing. So how do we fix that? We say, what features are being used for prediction? And somebody might say, well, we're just using the breed to determine if it's aggressive. And then ask yourself, does that make sense? And this is what machine learning systems don't do. They don't know how the world works, right? They don't know how the breed of dog leads to aggression because it's something in its brain. And then ask yourself, could there be another reason that this result comes from this data? If so, see if you can draw these kinds of pictures and then break the cycle by seeking rare examples, the positive deviance, the minority woman in college who, despite other minorities, systematically doing worse because they come from impoverished backgrounds, she's doing better, right? Study her and get her into your training data, right? Same thing with, maybe autistic people in the workforce that we might think, oh, they're autistic, therefore they're no use. Well, no, that turns out not to be true. There's all these things that are superficial characteristics that turn out not to be causative and that fit into these vicious cycle feedback loops. So I think I'm getting close to the end of my time, so I'm just going to give you guys a teaser about the other keys. And I'm going to flip through them fast, and you're welcome to ask me during the Q&A about these. Don't start with data. Biggest mistake in the world, okay? An AI project needs to start with the decision that you're making with that data and with that AI, okay? The reason is, if you start with the data, you'll be cleansing all your data, and 1% of the data gives you 90% of the value in your AI system. Again, we can talk a lot about that, but it's pretty radical because every AI person I know always starts with data. Predict unintended consequences. We learned about this earlier. This is the Facebook cycle where you go around, you're making money for Facebook, and that's all great because I'm getting to see ads that I like about things I want to buy. But it also creates these filter bubbles, which reduces exposure to diverse viewpoints, reduces our ability to separate truth from falsity, which actually undermines democracy if you believe a lot of people. So here we have this thing that we think is just this fun thing, and it turns out it has a really negative impact on democracy. AI is not a mature discipline. This is how most AI people think. They built the engine, and that's all they need. They don't need to actually build a plane. It's just about the engine, right? And a real mature discipline actually has best practices in many areas, and we can talk more about that if you want. AI is brand new. It's not mature. Explainable AI is not hard. Just ask somebody, don't just give me your model when you build the AI, tell me which variables we use. And if they say for that car, well, we predict its miles per gallon using color, whether it has detailed stripes or leather seats, you're going to be less likely to trust it than if it says we use weight, acceleration, and year of manufacture. So it's really simple. Again, it's one of these Pareto rules. You get 90% of the value from explainable AI, telling you how that thing works just by listing which features it uses. Guess what? It's not so hard. This is the future of applied AI. 5 years from now, we're going to be interacting with AI through immersive, game-like environments where we experiment with the future impacts of today's decisions according to different kinds of experts, and we create physics simulations. As you can see, as I'm paying more for trees, I'm getting out of the kind of post-carbon apocalypse, and the trees are growing very lush. But Linda Ritchie says, even if I pay for a lot of trees, her model, her research says that doesn't work. That's the future, and we can talk more about that too. But this is where AI is going. As it becomes democratized, it's going to be accessible to people through these sophisticated interfaces. And thank you very much. I appreciate your time. Happy to take questions.
Thank you.
Yep. So we do have time. You want to flip that around so that the microphone is.
So right. So how we usually do this, and I'm totally open to this. Speaker view. Okay. So for some reason I'm not coming up. Stop the video. Gallery view. Oops. My mug out of there. The reason why I put that up is because we can have people, if you want to ask questions, come up, and you can be on camera if you want. If some people don't want to do that, but we found another events. You've been in our other ones where that's been fine, but at least you can if you'd like. Are you okay?
We could pass that around. So
yeah, we've done it too. Sure. First, do you want to?
How was my audio, by the way? Do you think everybody understood what I said?
Yeah. I did. Yes.
Yeah, it's nice. I thought it was nice and clear.
Nice and clear.
Okay, good.
Yeah. So one thing we were talking about earlier, and if you have, because we have about another 20 minutes or so, and I think we could stay a little bit later, but you were talking about the kinds of problems people get into when they start to implement AI. So, you mentioned things like, the color and the stripe, but I bet you, lime green and racing stripes do correlate with low MPG, but it's, it's a very narrow set, right? I get that.
Sure.
Right? So what kinds of problems do people get into? Let's say they absorbed all your lessons, go back, and a week from now start an AI, project. They want to predict some customer behavior. What are the sort of problems you have to come in and mop up afterwards that you've seen?
Gosh, there's so many. I could probably list 12 to 20 problems in each of 4 phases, but I'll tell you the ones that are kind of my favorite fails. There was a telecom company once that brought me in, and what they wanted me to do was to build an AI that would predict the loss of a customer before they lost that customer. So they could give them a call and offer them a special deal. Oh, Jenny, we noticed that you might be thinking of a competitor. We want to give you a special discount or a free phone or something like that. Now, by the time they brought me in, they had spent 1.5 years cleansing this giant database and putting it into a master data warehouse. And it turned out that we could have done that prediction after only like 2 weeks worth of data management, because again, the factors that predict whether you're going to leave the company or not, there's only a few of them. And so one of the biggest mistakes I've seen is what I call gratuitous data cleansing. So often, and this is just something that's not taught to the AI PhDs. They say, well, the AI is only as good as the data. And that's actually not true. The AI is only good as the data fields that matter in the prediction, right? So I'm trying to think of an example, James, that wouldn't correlate, maybe the kind of spokes on the tires or something like that, right? Or if you're trying to predict whether I'm going to get cancer, you might say what kind of style of glasses I use, right? And that's really obvious, right? Because we know that what kind of glasses I wear doesn't cause cancer, right? Because we know how the world works. But in these more complex domains where we don't have that kind of insight, we can be really fooled, and we need to build models much earlier in the process before we waste huge amounts of time cleansing and managing and migrating data that's not needed. That's one of the biggest mistakes I've seen.
How do you know?
I can go on.
Yeah, hang on a second. Yeah,
can you just
please.
introduce yourself, like who you are, what you do, because so for her.
Oh, okay. Hi, Galina. I work at a bank doing technology there, and then also building my own product, starting my own business for career management. I'll be at your workshop next Saturday.
Oh, great. Look forward to seeing you.
So my question is, how can you identify which of those features has the most value? Because I'm going to go back to the last talk through Tech 2025 about the prisoner that was up for parole, and there was an assessment, and based on those questions, he was denied parole. And it was because one question had a much bigger weight than all the other questions, and it ended up skewing all of the other results.
Yeah, yeah. So there's two answers to that. One is technical, and the other is sort of outside of the machine learning box. The technical answer is you should ask people who are running those machine learning engines to work iteratively, to take some dirty data, build a model. The model was based on dirty data, but often it can still determine which variables are the most predictive. Clean up all of those variables, like maybe the top three. You know, in the car example, you might clean up this column of the weight of the car. Make sure you have all the accurate weights, and make sure you have all the accurate 0 to 60s, right? Then go back and build a new model with that clean data, measure the performance of that model. We didn't talk about how you can measure performance, but there's some pretty well accepted ways of doing that. If it's not good enough, then clean the next field and work iteratively that way. So that's the technical answer. The other answer is kind of the outside of the box thing, where you really need to think about how the AI is being used. And I don't know the recidivism example so well, so I'll give you a slightly different one. There's a great book called Weapons of Math Destruction, which I'm guessing some of you have heard of. It's about how algorithms go awry. And there's this teacher who's fired because the AI algorithm noticed that whether your students' scores go up one year to the next is a predictor of how good a teacher you are. Well, that sort of makes sense, right? If your standardized test scores go up, then you're probably a better teacher. Well, this teacher was fantastic, and the algorithm, because it didn't have that simple list of what features it used, right? So it was this black box. Nobody knew how it worked. And it turned out that because people hadn't sat down and kind of mapped out the context of the AI, and that's what I talk about in this book link, they hadn't realized that there's another reason that your scores might go up, and that's just the previous teacher of that class was cooking the books, right? Because her raise was based on the scores, and you're being honest, and so your class scores went down, right? And so that's a non-technical answer. We make so many mistakes with AI when we focus too much on the inside of the box, on the AI system, and not enough on the context in which we use it. And that's really the future of AI and what's going to be needed to get it to the next level. And that's what that book is about. That's what DI is about.
Can I follow up almost on what you were talking about? So, you know, it's funny because I think in AI, I was thinking about what's happening with face recognition software, okay? And I see that, I believe, maybe you can tell me that, you know, with the face recognition software, it can become like a Myers-Briggs in terms of when you're interviewing candidates, looking at them and trying to make those assessments, okay?
Right, right.
I see the problem, and you kind of alluded to this. Who's reviewing that assessment, right? And now there's the cultural biasness, gender biases, and so forth. So, you know, and we know the problem with those issues. So I guess my question to you is, you know, what are those pitfalls? Where do you see those pitfalls happening for moving in that direction, which I think will happen in the HR arena?
Yeah, well, that's a great question. And the example you gave is an example of something called using a proxy metric. So what we really care about is whether that employee will be successful. But of course, we can't see the future, right? So we use this approximation, which is their score on a test. And we need to take seriously and really engage with the degree to which the score on their test really is a good predictor of success. And you're absolutely right. One of the things that could get in the way of that being a good predictor of success is the variation in people who are administering the test, right? And the environment of the test. So we need to get serious about, it's funny, I see so many companies say, oh, we want to maximize customer experience. And I go, well, I know how to maximize customer experience. Give everybody $1,000, right? So, they go, we don't want to maximize customer experience. It's actually net profit, and customer experience is just a bad proxy for it, right? So you need to own that fact that it's just a bad approximation, and you need to have workshops with a diverse team of people in the room where you say, we know that the score on this test is a bad approximation of actual future success. Let's put our heads together and try to anticipate all of the things that can go wrong when we use this bad measure. But it's the best we have, right? So it's good enough maybe, but let's get conscious about the ways that this could fail. And AI can't do that part. That's what smart people need to do, and that's not about data. And this is why we don't start with data when we do smart AI. We start with setting up the problem in a smart way. It's a great question. Thank you.
Thank you.
I'm going to jump in then, Lorien, for a second about your
Sure.
messy data. One of the things I always advise my clients at Cognizant, although they didn't always listen, we had grown up the last, 50 years or so, or 60 of commercial IT, that the data had to be clean, garbage in, garbage out. I mean, who would argue with that?
Right.
Well, I would, for one thing. Now, granted, if you go to sell something, and the SKU beeps at the grocery store and it doesn't match their master file, that's a problem.
Right.
That's the kind of thing
Exactly.
that is ruled. But when you're saying, what's the comfort in the store? Does that affect, humidity and temperature? We have clients that do that, names you'd recognize. If that sensor was down, you don't say, I can't analyze it. There's mathematical techniques to work around it. So much of what goes into experience data is very subtle. The keystroke speed, how long did they linger on the page? I mean, for all we know, their child wanted to be fed or the dog was barking or whatever. You can use it because it's better than nothing, because the thing you're answering is not life-threatening. Don't make a medical diagnosis. Don't let the computer, do an incision. But if you're recommending a next best offer and you miss it by a little bit, who cares? It's better than throwing away the signals. And I have so many of my clients, and actually so many of my Cognizant colleagues, that would say the first thing we have to do is clean the data. And then that $50 million warehouse bill meant that they decided either not to do it or they did it 5 years from now.
You're absolutely right, James. Yeah. I'm glad you brought that up. And let me give you another language tool to help with this. And I heard there was a lady who was in banking a moment ago. There's operational versus analytical data cleansing. So operational, right, if you're a bank and you don't have the right numbers in my bank account, that's a big problem, or if you're a doctor or something, right? But that's a much higher bar for data governance than what you need. And we're in the middle of an election season right now. Think of polls versus votes, right? We can do an approximate and useful prediction using a poll, but that's not perfect data because, who knows, and we didn't talk to everybody. It's just approximate, right? But we still do polling. We don't say, we can't predict who's going to win the election until every vote is counted, right? So there are these two different levels between operational and analytical data cleansing. I have never met someone who understood that. I'm always saying it, and it's a huge issue. And, let me speak more generally. This skill, this field in which we talk about operational versus analytical doesn't exist, right? I don't know anybody who's come out of a PhD program or a data science program who gets the distinction you just mentioned, James. And so it really, really kind of puts a fine point on this fact that the whole discipline of how we use AI in practice is very, very immature.
And a related version of that is sampling versus census, like you said on the poll. I mean, for example, you talk about, there's a terabyte of data, per airplane ride on a jet, right, a Boeing or an Airbus. You really don't need to keep that terabyte more than a couple of days to prove that nothing happened. But you can sample it, right? When Progressive came up with their model of do you slam on the brakes, they have that little thing you can plug in, right? You don't want Progressive insurance. Yeah, they don't measure every second of every car. They did when they were designing the algorithm. And that's another common mistake is people talk about the exabytes of data being generated and how we need a gazillion servers before we can do AI. You really don't. An amazing amount will come out of sampling, which is what you talked about, Dr. Pratt, where the offline model development is really pretty data intense. The online execution, my cell phone recognizes human face with local processing power, but the algorithm to come up with that was done on, you know, a data center somewhere. And yet it's amazing how many people get that wrong. They still say we have to save everything.
The issue becomes,
So it's this picture here, right? So the top half of this picture takes a lot of time, where we use the machine learning to churn through the training data and produce a model. But then once you're using the model, it's really simple. Yeah, it's very fast.
Yeah, gotcha. I'm sorry, we had a question from the back here. Can you?
it's not so much, but
Sorry.
the issue becomes when someone says it's good enough and they let it go. It's good enough for whoever's programming it. It's not good enough for whoever it may affect. And that's where the disconnect of it being this giant person behind the curtain, as opposed to good enough is not good enough when it affects someone else.
So this is one of the things that we do when we begin with the decision. It's one of the key steps we take, is we say, how do we translate the inside of the box metric, you know, the measure of the pressure in the engine, and, you know, I'm just doing the metaphor, and the mix of chemicals in the carburetor. How do we translate those under the hood measurements into the measures that people care about, you know, net profit or customer happiness? And you must go through that exercise. Machine learning people, they'll use all this gobbledygook, you know, ROC and AUC, and you know, it's valid stuff, right? Don't get me wrong, but the exercise of translating that into what we need from a business point of view is not done, and that leads to huge problems, because guess what? It could be when you go from 4% accuracy to 8% accuracy, you save $10 million a day, right? So if you don't do that exercise, your machine learning guy is going to go, oh, 8%, that would never win a Kaggle competition, because they never got taught that 8% accuracy could have value. And they'll waste a huge amount of time when you could have deployed that solution and been making 10 million bucks a day, right? So you have to do that mapping from the language of the inside, you know, when you measure that machine learning thing, and say how good it is, to the business value or the business outcomes that you're trying to achieve.
And how often do you actually really get to do that? And with the timing that someone has hired you to execute, to do it, and then give results. That's where I also think there's a disconnect of, we need it now, as opposed to we need to take the time to look at build the black box, do the black box, and now see what the black box is saying and how to execute.
So my machine learning projects, some of them I do in 2 weeks, some of them I do in 2 years. And so there's no really good answer to your very good question, how long should it take? Generally speaking, the time it takes to build a good machine learning system corresponds to the size of the training data, but that's a bad proxy metric. It's really the complexity of the problem, right? And for really simple problems like separating Pitbulls from Chihuahuas, you can do it with 5 lines of training data. For more complex like machine vision problems, it might take, you know, gigabytes of data that you process over a few years. So it really depends on the size of the problem. But what's common to all of them is, don't start training until you know what your goal is, until you know that 80% using this internal measure will get me, you know, a huge amount of, you know, that'll get me my ROI on the investment in this project. And so don't try to, you know, over engineer these things. Often, you know, just a little 2% better performance than the baseline is fantastic. Sometimes, even if the performance is worse than the human system, it's great, because you save so much money by not using humans, and by automating it, it's great there too. So you have to ask those outside of the box, set up kinds of questions. I don't know if that answers your question. I tried.
Well, thank you. I'll just say thank you.
Do you want me to bring this down to you?
No, it's okay.
Yeah.
I just want to speak to the progressive example that you gave. That's like the everyday man.
Yeah.
So if you're using, say, the algorithm that is actually put together with the progressive, and they're measuring how many times you have an accident, we all know that the insurance companies are going to use that data, whether or not they're going to actually drop that person and they'll be able to get insurance. But that also affects whether or not they get hired. Because when you're looking at that data, and this person needs a driving record based on what progressive is using as an algorithm, they're using that. So when this person goes to look for a job, and if the only job that they can get is driving a truck or doing something else that involves operating a vehicle, that's going to eliminate them from getting a job. And if they're in a demographic where the only place that they can get work is actually operating an automobile or a truck, now you've affected a whole pool of people who can't find work.
Absolutely.
Can you just tell Dr. Pratt who you are? Because I don't think
I'm
she
sorry. I'm
Kim
Kim
Ellison. And what you do, right?
Oh, I'm an insurance consultant.
So there's an answer to that, which is to begin any AI project by brainstorming through your outcomes that you want to achieve. And achieving certain insurance financial targets might be one of your outcomes, but another outcome that you might all agree to as a company is not to systematically disadvantage any particular group. And when you use a DI approach and you have an open, safe brainstorming conversation about all of the goals you wish to achieve, and you don't start narrowly with the data saying, you know, we're just going to achieve this one financial goal or this one accuracy goal, then that helps to unlock those secondary goals that end up being really important, that if you ignore them, you're going to create these chains of unintended societal negative consequences that nobody wants to have happen. And so you need to start with the goals you're trying to achieve. And again, the best way to do this is a diverse team of people in a room. No data is allowed in the room. All you're allowed to do is brainstorm through what are the things we might want to achieve. And there's no crosstalk. You can't criticize. You can't analyze. The goal is just to list all the things we might want to achieve. And that practice alone, which you can do in half an hour, A, has huge power, and B, almost none of my clients do.
So I just want to push back a little bit on that. That was great. Thank you. Because the assumption I think that we are embracing here is that no one benefits from, you know, biases in society, and that companies don't want those biases. Actually, companies do benefit a lot of times from inequality, from, you know, systems that aren't fair. They actually can make a lot of money off of that. Okay. And so I think that's a reality that we are just beginning to, the CEOs, they're just, because they're losing a lot on that. You know, we have social media now. It's hard to get away with that type of behavior. And so my question to you is, when we look at what you say, which I think is a brilliant point, which is that we need to start with what we want the outcomes to be. How do you have that conversation with senior management that sort of makes them aware of the fact, or puts on the table that, you know, this is a negative outcome of what we're doing, but we've also benefited from this. And so if we take this off the table, we take this money off, how do we get this back? How do we change this so that it's beneficial in a way that we can quantify and say, okay, you know what I mean? Am I making sense? So how do you have that conversation?
So doing it this way shines a really bright light on hidden agendas. There's no question about that. I like to think everybody's good and they're sort of lost in complexity. And simply being serious about the outcome exercise, where we take the time to write it down and we make it conscious and we examine it and we make it a priority, isn't perfect, but it does have the benefit of surfacing hidden agendas. So somebody might be making a hiring decision that benefits, you know, people that look like them, for instance. And when you start to dig into the decisions they're making, you can say, hey, I think that achieves this other outcome that benefits this one group. And when you start to map the connection between the decisions they're making, you say, hey, I think the reason they make that decision is it benefits this group. And so by drawing pictures of the chain from the actions you take across to the outcomes and taking it out of this invisible space where it's just words going back and forth, it, generally speaking, shines a light on those hidden agendas. I'm not saying it's perfect, but it's definitely better than hiding within the invisible words we toss back and forth, or even a text document. Drawing pictures goes a really long way to saying, you know, to even talking about this action is going to lead to that outcome, and that's going to hurt us and help you, and let's get serious about that. And what's really cool is when you start to do this right, often you can find actions you can take that benefit everybody. That's the Holy Grail, right? Where you can find, by taking this seriously, the moves you can make in a space that a company realizes that if it does the right thing for that certain disadvantaged group, it can really benefit from that. And I'm seeing that, like the autism at work stuff is the one space I've been involved in a little bit. That can have a huge bottom line financial shareholder value benefit for a company.
Yeah, and I just want to almost love what both women have said. I think there's someone who's like almost, when I'm listening to what you're saying, there are almost three different paths. I'm going to take first Asia. China is one, where you're really talking about Big Brother, okay? And in some sense, we're moving down, right? So we're moving down this indirectly into this rabbit hole of control and assessment and amassing this control. That's path one. Path two, how do we then leverage biasness to make an economic value, right? Lending Tree, many lending institutions where we've used this information for biasness, right? So this is more of a social consciousness approach. So then finally, and I think basically what you said, like we said, how does it, what goes into it, what comes out? And to me, what really stuck is, what's the achievable, and who should we trust, right? So now you're really talking about who has this data, who's controlling this data, and what's the outcome they want to achieve. And in the case of how do you take that and then segment it to give us negative information to create a lending tree, and so forth, or again, so this, again, I'm going to go back to the, Big Brother is where we're at right now. And how do we manage control?
I agree. I'm an optimist in this space. Back in the 50s, computers were great big things that nobody understood. And Steve Jobs said, we're going to have a computer on every desk. And now we do. And so that technology, which used to be very asymmetric, has now been balanced a bit, right? I think the same is true of AI. Right now, we're in a very asymmetric period. There are these organizations that have these massive data stores and are building AI systems that, I agree with you, have some really, really negative potential unintended consequences. The good news is that if we learn what I'm trying to explain here, to cut through all the noise, we can become much, much more empowered and not just call those guys out, but also start to build our own AI systems and our own decision-making systems that can detect those problems. And so we can even that arms race a little bit. And so one of the reasons I'm here today is to help to empower you guys to understand what's happening, and hopefully, way more than just the few people in this room, to really start to understand, what's going on with AI so that they can call out, these outcomes. Because I think you're right. It's easy to hide within obfuscation, to say, oh, the algorithm did it, and then to check out, and that's not okay.
So I'm sorry, just to your point, since you're on that point, and we talk a lot about upskilling here at Tech 2025, and I tend to be not necessarily critical of upskilling, programs and companies, but we all know that when it comes to Amazon, which is spending, I think, upwards of $800,000 between now and 2025 to upskill, I think, 100,000 people in their workforce. We have PwC, which has spent, I think, $2.5 billion so far over the course of 3 years. So that's their plan to spend to upskill. They're upskilling in these technical skills, right? In AI and machine learning. And they're taking the non-technical, not just the technical people and upskilling them, but they're taking non-technical people, and they are sort of, I hate to use the word, but indoctrinating them or teaching them technical skills. My question to you is, and my concern is that the way that they are learning the skills that these companies are saying that they need reinforces the problem. I don't know that. I have not been in their training programs, right? And I understand that they have an outcome themselves, that they need to have sort of a narrow focus on their training. They have products that they have to get out the door, positions to fill. What would you say to people, ordinary people, who are going to need to upskill in the next 5 years? And I mean, in a realistic way, what would you say to them about how they should, on their own time, and maybe in their companies, suggest to their HR departments what they need to learn in order to make sure that they're getting this stuff right here that you're talking about, as well as anything else that they need? How do we do that on our own? And maybe ask our HR departments, hey, we want something else. We need something else.
It's a great question, Charlie. And I come to you from Silicon Valley with some really good news, which is there's a trend against this. I'm involved with an SAP program, which is really about taking engineers beyond code. And it's kind of it's what you might call an indoctrination. They use, the youngest people, the new employees, but it focuses on the consequences of technology, the ethics of technology, these outside of the box elements of how technology is deployed. And it's got 50% women in that technical program, and they are aiming for additional diversity metrics going forward. So there, I can't speak to Amazon or some of these other companies, but I do know that there's a backlash against the inside of the box, narrow technical only view of things. And there's, hundreds of people I know in the Bay Area and Silicon Valley who are very passionate about understanding the ripple effects of technology and the impacts that it has beyond the walls we've looked at in the past, and are trying to wake up and get conscious. And so to answer your question specifically, they need to focus on this new domain of applied AI, the outside of the box, because it's in the outside of the box that these problems happen. They need to not focus on new algorithms. We have plenty of kinds of car engines. We have plenty of algorithms, but they need to push their organizations to focus on understanding the unintended consequences of tech, how it's used, how it's measured, how it's built, how the data is processed, how it's planned, how it's assured and measured and checked to make sure that it's not going off the rails over time. And I guess the box I would put around that is, right now, again, most engineers, like, they're building the engines of the airplane, but for an airplane to be safe and usable, there's these engineering disciplines where we have to build all the other parts, and that's what's missing. So what I would encourage, folks who talk about on their own to learn about AI software engineering and what's special in that place. And I'm in the middle of writing a book about that, but it's very nascent. There's just not too many people talking about this right now.
Okay.
Thank you.
Well, thank you. I think you can see the group here, and we appreciate your coming.
Yes, thank you.
Thank you.
Yeah.
Awesome.
So you'll send
Thank
out
you. Those were awesome questions.
Yep.
They're great.
Yes. And Lorien, the workshop next week, Lorien travels the world doing workshops. I will send you her information, her presentation. Look, Dr. Pratt, is there anything else you'd like to impart to us tonight? And I know you'll give me information to share with them tomorrow as well. Is there anything else?
No, just a lot of gratitude for you guys making the decision within your own personal AI brains to take the time to learn about this. You're the pioneers, right? You're the guys who want to really understand how this technology is used, and don't let the technical people intimidate you, because you're answering the hard questions that haven't been asked.
Thank you so much. Yes, thank you very much, Dr. Pratt. Really appreciate it. James.